To our knowledge, Earth is the only place with life in our universe. But what makes Earth so special? The answer may be found in discovering our own beginnings. Life on Earth began long ago, but how did it begin, and why here? To understand why or how life on Earth exists, we must go back in time to when Earth itself was born. About 4.7 billion years ago, our Sun was born from the debris of a supernova. Dust and rock particles orbit the Sun and pull together due to gravity. Earth was born from the debris after millions of years. About 4.5 billion years ago, Earth looked entirely different than it does now. It was over 2100 degrees Fahrenheit. There was no air, only toxic carbon dioxide, nitrogen, and water vapor. Other planet-sized objects were orbiting the Sun around the same time Earth was forming. Earth is on a collision course with a large Mars-sized object. The impact is so powerful, it sends explosions of molten rock back into orbit. Gravity brings the particles back together and eventually forms the Moon. The Earth later cools. About 3.9 billion years ago, the Earth is still being bombarded with meteors and debris from leftover planet formations, bringing water, carbon, and proteins and other elements to Earth. As the Earth cools, a crust forms and the water is allowed to pool. 3.8 billion years ago, molten rock pushed up from under the oceans, forming giant land masses, small islands at first, due to volcanic activity. However, the Earth is still super hot and toxic with unbreathable air. Chemicals from the water combined with heat and light eventually created small organic molecules, and somehow, life happened. RNA appeared, and shortly after, amino acids led to DNA replication, and life as we know it caught hold. Cyanobacteria increased the oxygen levels, and eventually eukaryotes showed up. 1.5 billion years ago, multicellular eukaryotes, probably algae, arrived and life supernovaed. The Cambrian explosion created animal diversity and evolution at a whole new level. Climate fluctuations, extinction events, brings us up to today. Adapting and evolving has been part of Earth's history. Every action creates a reaction. Other planets, much younger in this process, could provide a home for life in the distant future. The sixth largest moon of Saturn has been called the most promising bet for life. Enceladus has a welcoming temperature and likely water. The surface of the icy moon is thought to be about 99% water ice, with a good chance of liquid water beneath. Observations suggest the presence of carbon, hydrogen, nitrogen, and oxygen, organic molecules thought to be necessary to develop life. It might have a boiling core of molten rock that would be able to heat the world to toasty temperatures needed to give rise to life. Jupiter's moon, Europa, also seems promising due to its potential water and volcanic activity. Though the surface seems to be frozen, some scientists suspect that buried underneath is an ocean of liquid water. Volcanic activity could provide life-supporting heat as well as important chemicals needed by living organisms. Microbial life could potentially survive near hydrothermal vents on Europa, as it does on Earth. Our next-door neighbor Mars, the red planet, is also a front-runner for life. It is the most Earth-like planet of our solar system, with a comparatively similar size and temperature range as our own planet. Large bodies of water ice lie on Mars' poles, but there's a reasonable chance of liquid water beneath the surface. Evidence suggests that Mars may have also been more habitable in the past. Geologic features imply that liquid water once flowed across the surface, and volcanic activity, now dead, once flourished. Titan, Saturn's largest moon, also looks like it may have hosted life. It has a thick atmosphere rich in compounds that often mark the presence of living organisms. It is filled with methane, which is usually destroyed by sunlight. On Earth, life constantly replenishes methane, so it might similarly be responsible for the methane on Titan. Titan, however, is very cold, and if liquid water exists, it must be deep beneath the frozen surface. Io, another moon of Jupiter, is one of the few moons to support an atmosphere in our solar system. It contains complex chemicals promising for life. Volcanic activity on the moon also makes it warmer than many others. Its violent surface seems inhospitable, with temperatures often too cold or too hot to support life. So is there life on other planets or moons in our solar system? We must explore our own past to unlock the secrets of life to find out.